Hello, and welcome to my series of videos in which our objective is to study for and pass the certifications that are commonly known as the trifecta of CompTIA certifications. That is to say, A+, Network Plus, and Security Plus. So I thought I'd start by tackling networking. Networking, put simply, is the ability of two or more computers to communicate with each other. This communication takes place by sending and receiving data. In order to send and receive data, there must be a common set of protocols. And the most common set of protocols are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. So I thought I'd start with Transmission Control Protocol. This is defined in RFC 793. RFC stands for Request for Comments. Basically, Request for Comments is a technical document that basically outlines the protocol in a very technical sense. You can type in RFC 793 into a search engine and you'll find the document, and you can read it, and it goes into more depth than this video. You don't need to know it for purposes of the exam, but you'll obviously gain more knowledge about Transmission Control Protocol. Conceptually, it operates on the fourth layer of the OSI 7-layer model, the transport layer. It also exists on the second layer of the OSI 4-layer model, the transport layer. But we'll get into the OSI 7 and 4-layer models in a future video. Basically, Transmission Control Protocol is a connection-oriented transport layer protocol, and what makes it unique is that you must establish a mutually acknowledged session between two hosts before communications take place. If the three-way handshake does not take place, then communications cannot take place. So we're going to go into how TCP works. It works via three-way handshake, SYN, SYN-ACK, and ACK. With SYN, the client tries to initiate a session with the server. With SYN-ACK, the server acknowledges the session and sends packet back to the client. With ACK, client sends an acknowledgement packet back to server. And then once ACK takes place, then communications can take place. So it's been said that a picture is 1,000 words. Maybe this is at least a paragraph of so we have, like, here's a diagram. Here's the client, and on one side you have the server on the other side. So the client sends SYN, and then so the server receives SYN, and then the server sends back an acknowledgement of the SYN, which is SYN-ACK. The client receives the SYN-ACK, and then can send the ACK, and then the server receives the ACK, and so it knows that it can send. It basically establishes the connection. So, as you might have guessed, it's very easy to break this. I'm going to go to the next slide here. This is how an attacker can basically break the three-way handshake by sending a SinFlood attack. With SinFlood attack, it just keeps sending a bunch of SYNs. The server sends back an acknowledgement, the attacker doesn't send in. This is basically unique because the attacker doesn't send back an ACK and does not establish a connection. Then you see the visitor tries to connect, and the connections are exhausted. There are different ways of defeating a SinFlood attack. One of them is you can have a firewall that just sees who's sending out the who's sending out the SinFloods and blocks that IP. This works if it's a single attacker, but if it's a distributed attack, it may not work. There's other ways of dealing with this. Another way is you can basically cancel out the half open connections. But what this acknowledges to me is that basically when TCP was being designed, they didn't necessarily figure out that how different ways that people could break it. But anyway, that's just my view of it. Let's go to the next slide. Okay, well, and there's another. The other protocol here is user datagram protocol. And this is defined in RC 768. It's a transport protocol, but the big difference is that it does not guarantee delivery like TCP does. It's basically set it and forget it. It's fire and forget. It's a connection less session. No session is established between the sending and receiving hosts. So, and you'll see, like, basically, TCP is used for sessions like downloading a web page, or downloading and uploading an FTP file where reliability is necessary. UDP is used for things like VoIP, where if you drop a packet, it doesn't really matter that much. Okay, here we have the examples here. Example stream media session. So basically, Skype, SIP, session initiation protocol. If a packet is dropped, it is not asked for again. Fire and forget. There may be some packets missed, but so you can see where if you're downloading a file and some packets are missed, this is important because you're not going to basically a binary is not going to run on your computer if there are some packets missing. But a UDP transfer is more efficient and economical. TCP, for example, has 14 fields as its header. UDP only has 4 fields. So that concludes our summary of TCP versus UDP. I'll see you in the next video.